Hello, in this video let's look at how to get the quotient rule using the product and chain rule. So we will use, we have a quotient rule because we divide in two functions. And right now the g function is to the first power. But if we want to write it as a multiplication, then the g function has to move up on the top. And when that happens, the power on the bottom changes the sign. So instead of having g to the first power, we're now going to have g of x to the power -1. But we now have a multiplication. So we have changed our quotient into product. Now when we do the derivative, we will need to use the chain rule as well. So the product rule says we take a derivative of the first, which is f prime of x, times the second g of x to the -1. Plus, now we keep the first function and take a derivative of the second. Well, the second is to the -1. Derivative of anything to the -1 using the power rule is -1 of that quantity to the -2. So we have g of x now to the power -2. But the inside of this -1 question was not just x, it was g of x, which means we need the chain rule as well, because we have a composition of functions. On the outside we have something to the -1, on the inside is more complex expression than just x, which means we need chain rule. So we multiply by the derivative of the inside, which is the derivative of the function g. The tick marks, of course, indicate the derivatives. So here we're doing derivatives, here we're not. Here we're doing derivatives, nowhere else is the derivative. Now let's change all the exponents from negatives to positive. So that means we're bringing all of those terms down, which means we have f of x, f prime of x, divided by g of x. Then we have a minus because the plus times minus is a minus. F of x times g prime of x divided by g squared. And in order for us to combine the two fractions into one, we need a common denominator, which of course is g of x squared. So what needs to happen is we need to multiply both sides by g of x. If we do that, we will get g of x times g of x and g of x on the top. Now let's put it all together and we will have exactly the same formula as the quotient rule. So the bottom is g of x to the power 2, and on the top we have f prime of x times g of x minus f of x times g prime of x. And that's how to change the quotient into product and still end up with exactly the same result, because this is the same formula as the quotient rule. Now let's do it on a practical example. So here a little bit below I have the same example written twice. And the first time let's solve this example using the new technique, changing it to product. And the second example, let's do it using the original technique, which is the quotient rule, and see if we get the same result. So the first thing is, and for those of you who are already convinced, that would be it. But for those of you who are curious to see how that works in practice, that's what this is about. So let's do the first thing. The first thing is changing into product. So we have x cubed times 3x plus 8 to the -2. Now we're taking a derivative of this product. The derivative of the first term is 3x to the 2 times the second unchanged plus the first unchanged times the derivative of the second. The second is something to the -2. That's a power rule and a chain rule. Derivative of something to the -2 is -2 of that something to 1 power less, which is -3. And then of course by chain rule times the derivative of the inside function. The inside is 3x plus 8. The derivative of it is just 3. Now all of the powers that are negative go on the bottom, and we have 3x squared divided by 3x plus 8 squared. Then we have -2 times 3, that's -6. We have x cubed on the top, and then on the bottom we have 3x plus 8 to the +3. So this negative we have here is between the two fractions. Now to combine the two fractions, all we need is common denominator, which is 3x plus 8 cubed. So all we need is extra 3x plus 8 on the top and on the bottom. Now we have 1 fraction with 3x plus 8 cubed on the bottom, and simplifying on the top, 3x squared times 3x is 9x cubed. 3x squared plus 8 is 24x squared. Now minus 6x cubed, combining like terms, 9x cubed minus 6x cubed makes 3x cubed plus 24x squared divided by 3x plus 8 cubed. Now that's the final answer to our question using the new method. Now let's do the same exact question using the quotient rule. So the quotient rule is if we have two functions, the one on top is called high, the one on the bottom called low, then the quotient rule is low d high minus high d low over low squared. So that's a mnemonic device to rewrite in the quotient rule, which we already have written up above. So this is exactly the same. This is the same as this. So all I'm doing is reminding myself what that formula is with this mnemonic device. So let's apply the formula now and see what we get. So our low function is 3x plus 8 squared, the high function is x cubed. Now let's take a derivative. So we have the low, that's 3x plus 8 squared, times derivative of high, that's derivative of x cubed, which is 3x squared, minus high, that's x cubed, times the derivative of low. The derivative of low is the derivative of 3x plus 8 squared. Using the power rule and the chain rule, we have the derivative of anything to the 2 is 2 of anything to the 2, the derivative of that is equal to 2x to the first. So we move the power to the front, and now we have to the first 3x plus 8. Now, because our inside is more complex than just x, we need the chain rule. So we multiply by the derivative of the inside, which is times by 3. And on the bottom, we have our function 3x plus 8 squared, and now we square it again. When we square it twice, 2 times 2 becomes 4, so we have 4th power on the bottom. So let's change that right away, because we know what that is. So this is to the 4th. Now we can see that we have 3x plus 8 in both of these terms, so we can cancel one of them. So if we cancel one from here, and one from here, we would now have the bottom is now cubed. On the top we have 3x plus 8 times 3x squared minus 2 times 3, that's 6, x to the third divided by 3x plus 8 to the third. Now let's clean up the top and see what we get. 3x squared times 3x makes 9x cubed. 3x squared times 8 is 24x squared minus 6x cubed divided by 3x plus 8 cubed. Now combining like terms, 9x cubed minus 6 makes 3x cubed plus 24x squared divided by 3x plus 8 to the third. And that's the final answer using the quotient rule. Now let's look at the two results side by side and see if they match. 3x squared plus 24 divided by 3x plus 8 cubed. They're exactly the same. And that shows that we can indeed use the multiplication and the chain rule instead of a quotient rule. And that's what that video was all about. If you have any questions on anything, please let me know. Thank you for your time.